Greetings to all present. I am here to present the paper Optimizing New Zealand Construction Consolidation Centers, Defining a Research Framework. I am Kamal Dhawan, the presenting and corresponding author for this paper. During the presentation, I will talk of the construction industry in general and the New Zealand construction sector in particular, the research opportunity that triggered writing this paper, research contextual to New Zealand, transport externalities, construction consolidation center, its definition, implementation perspectives, and existing benchmarks, and possible research directions. The construction industry has certain typical characteristics. It moves to where work is and is project based, each project being unique. It entails repetitive reconfiguration of the supply chain, which is customized to the project, the execution phase, and the actors involved. It is highly fragmented and individualistic. Construction materials are low cost and high volume, and transport is fundamental to its operations. The barriers to sector transformation are complicated and unwieldy hierarchies, leading to adversarial relationships. Lack of a coherent business strategy, the operations being precedence based. The tendency to pass risk rather than eliminate or share it. Best for individual attitude rather than best for project attitude. Delineation of the design and production processes. Highly competitive tendering and scarce use of technology. The New Zealand construction sector is isolated from the rest of the world owing to its peculiar geographical location. It responds comparatively slowly to improved philosophy, resulting in delayed introduction of new ideas. This typically lags UK initiatives by about 8 years. In turn, new initiatives to upgrade construction have major knowledge, understanding, and skills deficits. Its productivity compared to peer domains has not been very encouraging over the last about 30 years. In April 2019, the Construction Sector Accord was launched between the government and industry leaders, creating a platform for them to work together to meet some of the key challenges, including skills and labor shortages, unclear regulations, lack of coordinated leadership, uncertain pipeline of work, and a culture of shifting risk. This was followed up by a 3-year construction sector transformation plan during January 2020, a blueprint for resolving the sector's long term challenges around risk, overly complex contracts, and skills development. The research opportunity has been provided by Watercare, an Auckland Council owned entity providing water, wastewater, and stormwater services across Auckland. They have recently commenced a program to deliver capital water infrastructure in the Whangaparoa Peninsula under a $2.4 billion contract with their supply chain partners over 10 years. It adopts program alliancing as opposed to project by project alliancing from the enterprise model of Project 13 of the UK as a strategic infrastructure delivery vehicle. At the operations end, it has adopted the Construction Consolidation Center approach as a logistics solution. Both the initiatives are a first in New Zealand, the portfolio-based delivery being a step change in infrastructure procurement. Aiming at 40% carbon and 20% cost reduction by 2024 and 20% health and safety improvements year on year, they create a unique contextual research opportunity, permitting performance benchmarking against previous research in Europe, continental USA, and Australia. Contextual research has been enabled by implementing logistics differently in the form of a construction consolidation center under a collaborative delivery model. The CCC permits close examination of outcomes of modified vehicle movements and fleet composition. It also permits scenario building by superimposing operational data collected onto recorded performance data of cleaner technology vehicles. The collaborative delivery model enables observing strategic implementation of logistics in the wider domain of supply chain management and project delivery in a manner different from the way it has been implemented in New Zealand so far. The concept is in agreement with the IPCC 2014 report and the New Zealand Energy Strategy to 2050 in reducing kilometers of freight transport, restructuring freight logistics, increasing load factors, and implementing low carbon transport. Construction material being low cost and high volume, transport is a major component of construction logistics. Estimates show that transport is responsible for nearly half the construction logistics cost, about one-fifth of the construction costs, and almost a tenth of the selling price. In addition, it is a major energy consumer and significant generator of emissions. Construction transport consumes nearly 40% of urban oil, causes between 16 to 50% of urban pollution, and leads to many times higher fatalities compared to other modes of transport. Related negative social and environmental impacts are damage to biodiversity, noise, congestion, accident risk, gridlock, adverse public health, to name a few. Effects of transport within and outside the domain are therefore substantial, and optimization can have a major positive contribution in terms of reducing or mitigating negative impacts. In the New Zealand context, freight transport is a major contributor to the greenhouse gas emissions annually, and negative social and health impacts such as pollution, noise, crashes, and community disruption. A comprehensive definition of a construction consolidation center is on the screen. It effectively captures the concept of cross-docking with modal transfer, if required, and reduction in transport by optimal capacity utilization. It also points in the direction of decoupling trunk movement of material from local or retail delivery to site. A CCC may be seen as a purely transport solution or as a business opportunity. As a transport solution, it is comprised of three components: the demand of goods, the supply of goods, and the physical environment within which this demand and supply take place. Each of these is linked to one or more stakeholders. Receivers generate demand for goods, shippers send goods to fulfill this demand, and logistic service providers undertake deliveries as a direct result of the interaction between receivers and shippers. Local authorities regulate contextual movements, and citizens inhabit the physical environment where all this takes place. As a business opportunity, it provides services to businesses who cannot afford it or do not have the associated management skills. These may be associated with distribution network management, terminal facilities, delivery and tracking, e commerce, and administration. Some or all of these may be employed based on individual supply chain requirements. A CCC, when optimally utilizing vehicle capacity, creates certain advantages for freight carriers, CCC operators, receivers, other road users, and the environment. These are reducing delivery time and unit delivery cost, revenue generation by utilizing the time saved, reducing unloading time, reducing number of trips and kilometers, reducing traffic levels and associated problems, improved reliability of deliveries, fewer but larger deliveries, reducing the time to receive them, holding stock at the CCC, freeing up staff time by using the CCC for pre-retail services, reduction in fuel consumption, pollution levels and noise, and the possibility of using alternate propulsion technologies. As disadvantages, there are concerns about handing over goods to a third party, reduction in contact with customers, addition of CCC operating costs, and increase in traffic levels near the CCC with its associated problems. There are existing documented benchmarks for the operational benefits accrued from establishment of a CCC. These are connected to the use of transport features, use of storage space, and the pre-retail activities. A CCC permits improved waste handling, reduced stockouts, improved return service, higher availability of products, use of low impact vehicles, and overall improvement in the delivery process from its transport functionality. The storage space at the CCC permits greater breadth and depth of product variants to be stocked and enables their availability for retail utilization. Pre-retail services enable more staff time to be utilized gainfully, assistance to customers, and off-site construction, reducing raw material stocking and reducing construction effort on site. The environmental benefits accruing from CCC as a transport solution can exponentially increase by utilizing alternate propulsion technologies for freight transport. Fossil fuels, with their high pollution levels, barely achieve energy efficiencies of approximately 13%, while all electric vehicles at the other end of the spectrum are much cleaner and demonstrate energy efficiencies of up to 73%. Alternate fuels such as CNG and LPG and hybrid technology occupy intermediate positions within this spectrum and are potent means to reduce environmental externalities till all electric implementation is achieved. While the research that is the genesis of this paper is operationally focused, the possible research directions presented by a CCC in New Zealand may be many. The graphic on the screen shows certain research domains, research questions, and outcome possibilities from the center outwards. These are by no means exhaustive, and many more threads may be drawn from the fabric of the contextual research opportunity in the form of this unique implementation of infrastructure delivery.